Hello everyone, my name is Richard Jang, and I'm a technical marketing engineer here at Cisco's Wireless Enterprise Networking Department. Today, I'm going to be providing you with an overview of one of Cisco DNA Center's newest assurance features, Intelligent Capture. This state-of-the-art intent-based networking solution has the purpose of allowing a network operations team to resolve any wireless issue, not only quickly and efficiently, but also remotely. From this video, you'll learn about the various customer pain points existing today in wireless, the use cases of this feature that solve those problems, some prerequisites that will help you get started, as well as a live feature demo. Now, to get started, let me provide you with a common day-to-day scenario in regards to how a network operations team might be handling a live wireless issue today. Imagine we have a network operations specialist named Fred. His primary role in the company is to maintain his company's wireless network in a healthy state and to resolve any employee issues in the network. His goal is to ensure all employees have a great wireless network experience and can focus their attention on being productive. But let's say we have a scenario in which a single employee has opened an IT ticket complaining that his laptop is unable to connect to the wireless network. How would Fred debug this issue? Without Cisco DNA Center's Intelligent Capture to provide an immediate technical insight into the problem, Fred would have to begin manually inspecting each component of his network infrastructure for the root cause. If Fred is unable to root cause the issue from the data he's able to collect from his controller or access point, his next step would be to pay that employee's location a visit and take an over-the-air wireless packet capture to investigate what part of the 802.11 handshake is causing the laptop's onboarding process to fail. Upon collecting this packet capture, he now has to spend large amounts of time analyzing the data before anything could be potentially concluded. As you can imagine, this process is not only incredibly time-consuming, but also impractical. Now picture 10 employees filing the same complaints. It would be nearly impossible to scale this troubleshooting efforts properly, resulting in time being wasted. With that being said, this is where Cisco's Intelligent Capture solution comes into the picture. To provide you with an understanding of this feature's power and capability, we're going to dive into the high-level use cases of this feature. For our first use case, we have data capture and live capture, which provides our access points the ability to schedule a packet capture on any client in the network directly from our DNAC platform. When enabled on a supported access point, the access point will send both the management and data packets directly to our DNAC platform, where the user will be able to view it on a graphical user interface. For our second use case, we have anomaly detection, which provides our access points and the controllers with the ability to intelligently identify the exact reason why a wireless client is having issues joining the network. In addition to providing the user with a packet capture of the exact issue, the user will even be provided a plain text message explaining to them exactly where in the onboarding process failed. For our third use case, we have AP and client statistics, which will provide users with a live in-depth analytical view of the various wireless metrics that could play a role in an AP or client's connectivity or throughput. For our final use case, we have spectrum analysis, which will provide our user with a beautiful as well as accurate visualization of the RF noise and interference surrounding each of their supported access points. All of what I've just explained can be easily done by a single user from a single laptop from anywhere in the world, which is why this is such a powerful feature. With that being said, let's dive into how this feature really looks with a live demo. In this demo, I'm going to be starting off with a high-level day zero run-through of how we would initially discover our network infrastructure on Cisco DNA Center. And upon completion, I'll then be diving into the in-depth day one drill down of how we will use Intelligent Capture to monitor and troubleshoot our network. If you are already familiar with the day zero process of Cisco DNA Center, you can go ahead and click on the annotation that has appeared on the screen to skip directly to where I'm enabling the features of Intelligent Capture. When we initially log into Cisco DNA Center, we will show up at this homepage. The first thing we want to do is add our controller and access points into the system. We can start off by opening this hamburger menu at the top left-hand corner of the screen, clicking on Tools, Discovery, then Add Discovery. And here, we can go ahead and include our controller name, controller IP, subnet, as well as include any login credentials such as SSH username and password, as well as SNMP read and write credentials. After filling in these details, we can go ahead and hit Discover. For the purpose of this demo, I've already discovered one of my controllers, and as you can see on the right-hand side, everything is successful. Now that our network devices have been discovered, our next step is to create a site hierarchy which depicts where our network infra is located in real life. To do so, we can open up the hamburger menu, go to Design, and then Network Hierarchy. Here, you'll notice that I already have a number of areas created on the map, such as Los Angeles, Palo Alto, and Pleasanton. The typical hierarchy of a site is by area, which is typically maybe a city, then building, which is your company's building within that city, as well as a floor within that building. In order to create these, you can go ahead and click on the cog button next to any of these sites, and you can create a child site within. For the purpose of this demo, let's go ahead and assume that I've just created this Los Angeles site. Now that we have our site created, we can go on to our last step of configuration, which is assigning our discovered wireless controller and access points to the buildings and floors. To do so, we can open up the hamburger menu again, click on Provision, and then Inventory. To view the devices we've just discovered, we can navigate to the Unassigned Devices section on the left. Here, you'll see the controller and its two joint access points that we just discovered. So typically, a controller is assigned to a building, and an AP is assigned to specific floors within that building. So let's go ahead and click on the checkbox next to the controller. Let's go to Action, Provision, Assign Device to Site, and let's choose a site. And let's choose the building within Los Angeles. Save, and then Next, and then Assign. So now our controller is within the building within Los Angeles. Let's assign our access points now. Action, Provision, Assign Devices to Site, and let's go ahead and choose a floor. So within the site, I only have one floor, floor 3, so let's save, and let's assign both of them to the same floor, hit Next, and then Assign. At this point, both of our controller and access points have been assigned to the proper site, and we can now enable the two passive features of Intelligent Capture, AP and client stats, as well as anomaly detection. In order to do so, we can go back to the hamburger menu, go to Assurance, and go to Intelligent Capture Settings, and then Access Point. Here, you'll find our two features, AP Stats Capture and Anomaly Capture. And for both these features, they give us ability to either disable the feature, enable it on a per AP level, or at a global level, which means that all APs joined to the WLC will have the feature enabled. For the purpose of this demo, I already have it enabled globally, so all my features have this enabled already. Now that two of the Intelligent Capture features are enabled, let's go ahead and start the day one portion of this demo by navigating to the Intelligent Capture client page. I've already connected a wireless client to my network beforehand, so I can visit that client's Intelligent Capture page by clicking on the magnifying glass at the top, pasting in the client MAC, clicking on the Client 360 button, then clicking on Intelligent Capture. Now, we've entered the Intelligent Capture client page. The purpose of this page is to provide users with as much live technical details regarding this client as possible, so that any issues seen can be quickly root caused and resolved. Let's go over the features one by one. To get started, let's assume that we're currently looking at the client of a complaining employee who was occasionally having issues with their client joining the network earlier in the day. First things first, Intelligent Capture allows us to go back in time for up to 14 days, so if you've missed the moment a complaint was made, you can simply go back in time by clicking on this clock here, choosing a specific time or day, or expanding the time slot of this page by clicking on the drop-down menu here. Let's go back 5 hours ago to 4 p.m. when the issue had occurred. Moving on, if you've integrated CMX with Cisco DNA Center, we can actually view the location of the client as shown here by the dot in the heat map. This way, right off the bat, we can immediately have a sense in regards to the surrounding RF environment of the client and can think of everything relative to that. Next, up here at the top, we can see it says Data Packet Capturing. This is the data packet capture feature we've discussed in the beginning, and it will allow any supported access points to continuously capture both the management and data frames of the client. Then, the access point will then send the natively encrypted data frames in a decrypted form that will allow a user to validate the L2 and L3 QoS consistency, TCP level retransmission, and other application level handshake details in a manner which would not normally be possible. For this demo, I already have the feature enabled. However, if you want to have it enabled or disabled, you can simply click on the button here. If you would like to view the packets, you can click on the download button and then choose a PCAP file that you would like to view by clicking here and then opening it up in Wireshark. Now, I can add a filter to my Wireshark, and now I'm able to view the decrypted TCP data frames for my client. Looking into these packets will provide me with the crucial information such as timestamp and radio header information such as RSSI, channel details, and much more. As you can see, the power of data packet capture is that it allows us to have a packet-level insight into any client on the network from anywhere in the world, rather than needing to physically visit the client's location. Going back to Cisco's DNA Center, to the right of the data packet capture feature, you can see it says Live Capturing, and this is where you can enable or disable our Live Capture feature. When you enable this feature, we're actually enabling three things. We're enabling an access point to capture all onboarding packets of the client, enabling the access point to send client statistics shown in the charts below at a rate of 5 seconds opposed to the usual 30-second frequency, as well as enabling the controller to send client onboarding events, which are shown on the left, at a rate of 2 seconds opposed to the usual 30-second frequency. Essentially, the purpose of this feature is to home in on a particular client you want to debug and provide as much information as possible in live time. Let's look into the onboarding packet capture feature first. If you look at the onboarding events viewer on the left, you'll notice all of these events have a PCAP symbol next to them. This is where Cisco's DNA Center will show the onboarding packets. Essentially, the packet captures are being mapped to a specific onboarding event so that the user can understand when these packets were actually captured. You'll also notice that some of these events are green, whereas some of them are red. Intuitively, the green event symbolizes that the event had occurred successfully, whereas the red event symbolizes that an anomaly has occurred in that event. Why don't we go ahead and click on one of those red events? Right away, you'll notice at the top that it provides you with the exact description of the issue, which is client is blacklisted due to the repetitive association authentication failure. This is the issue that the controller is claiming has caused this failed event. Scrolling down, we can see the Auto Packet Analyzer, which is Intelligent Capture's packet visualization tool. It essentially breaks down the packet capture that the API sent into a beautified graphical user interface so that the packets can be easily interpreted. As you can see, it includes details such as the packet types, the packet direction, any failed packets, RSSI, and many more. We can even download these packets, so let's go ahead and do that and see if the packets match up with the failure reason that Cisco's DNA Center was claiming. Here, we have our anomaly packet capture. As you recall, the issue that we saw was client is blacklisted due to repetitive association authentication failure attempts. From these packets, you can see a clear bombardment of association requests from the client to the access point. The access point had already responded with an authentication packet, however, the client is still responding with another association request again and again. As you can see, Cisco's DNA Center immediately takes out the most difficult part of the troubleshooting by providing a protocol-level insight and root cause analysis, which will save any team tons of time. To go a step further, we can take a look into the client RF stats below, which include these metrics such as RSSI, SNR, data rates, TX-RX packets, and TX retries. When you view these stats after clicking into an event, you'll notice a white and gray section. The white section essentially represents the time frame in which the packets above were captured. This gives you a further view of the different wireless metrics that were occurring at the time of failure. For example, in our case, we had incredibly low SNR and no TX and RX packets. It could potentially be telling you that the signal strength between the client and AP was very weak. Going above and beyond, if you've integrated Cisco's virtual network analysis module into Cisco's DNA Center, You'll even have access to the information such as packet loss, wireless delay, or even jitter for the different application protocols shown here. With all this information on the page, any difficult wireless issue is suddenly made easy. With that being said, this concludes the overview for the Intelligent Capture client page. Let's go on to our next feature by making our way to the Intelligent Capture access point page. To do so, we can navigate to our hamburger menu, click on Provision, Inventory, and then click on the site that contains the AP we wanted to view. Let's go to the San Jose Building 14 site, which contains the Catalyst 9130, which is also Cisco's newest 11AX flagship access point. Now, let's go ahead and click on that circle with the 3 dots, and now let's click on the View 360 button. Now, let's go ahead and click on the Intelligent Capture button to enter the Intelligent Capture access point page. Here, you'll immediately be met with an immense amount of data. So how do we interpret this? For starters, you'll want to understand that by default, this page is showing you the various wireless metrics for specifically serving radio 0 of your access point, which is shown here at the top. However, if you click on this menu here, you'll be able to switch to the metrics of my AP's other serving radios as well. For my access point, you'll notice that it lists radio 0, radio 1, as well as radio 2. This is because my access point has 3 physical serving radios. This menu will change based on the physical capabilities of your access point. Let's start off by taking a look at this first dashlet. Here, we have the trending client count for the past hour. You'll be able to see that at the beginning of the hour, I had more clients than what I do have now. For the next dashlet, I have the top clients with TX failed packets by SSID. If I click on this drop-down menu to the right, I'll be able to toggle between the different SSIDs that my access point is broadcasting. Let's click on one that I know I have clients connected to. Here, it seems like I have no failed TX packets, which is actually a good thing. However, if I was ever facing any connectivity issues with this AP, I would come to this dashlet to see if a particular WLAN is having issues. For the next dashlet, we have channel utilization, and this one is broken down into 3 categories. This AP, which is quite literally this access point, other Wi-Fi, which is other nearby access points, and non-Wi-Fi, which could be various interference from the 2.4 GHz, such as Bluetooth, or perhaps even microwave if the access point is next to a break room. Going on to the chart on the right, we'll see a further breakdown of the channel utilization for this AP's radio. If you look at the table on the right, you'll see that there includes information such as what clients and how many packets are contributing to this channel utilization percentage. Next, we have the TX frame counter per type, which shows the data and management frame count. In this particular case, you'll notice I have a ton of management frames, but very little data frames. This is because I have many clients joined, but no actual traffic being passed. Wrapping up this page, we have total frame error over the air, which are the TX and RX errors, followed up by TX power and noise floor, which can give you an insight regarding how much the power of your AP's radios can compare to the surrounding noise. Then lastly, we have the multicast and broadcast counter. Going back to the top, if I click on the 5 GHz menu, you'll observe that the same data is seen, but just for different one of my AP radios. Adding on a bit more information, let's assume that we've observed the issue in the past, but did not have a chance to go and look at it until a couple hours later. The network time travel bar at the top will allow us to go back in time for up to 14 days to observe this issue. Furthermore, if we really wanted to drill down to a particular moment, we can actually drag our cursor on the section of time of the dashlet that we want to look closer into, and the dashlet will zoom in. As you can see, this page really leverages you with a ton of information that will help you get to the bottom of any wireless issue. With that being said, let's go ahead and move on to our final intelligent capture feature, spectrum analysis. We can navigate to this page by going to the top and clicking on the spectrum analysis tab. Now, we've entered the spectrum analysis page. To To provide you a background, similar to the AP RF stats page, the spectrum analysis page will allow you to toggle between the 2.4 and 5 GHz band, which will change the graphical user interface to display the RF spectrum energy levels according to what's chosen. As you can see, there are two main charts on this page. The top is a channel frequency by amplitude chart, and the bottom is a channel frequency by time chart. So how do we interpret this? Well, at an initial glance, this chart will provide you with a visualization with regards to what channel frequency and amplitude has a higher level of RF spectral energy. By default, this page will be showing you this RF data in a persistent FFT view, which means that it can capture interference patterns and RF signatures by overloading the burst real-time FFT sweeping. If I enable this real-time FFT button at the top here, the chart will show me the incoming spectral energies coming in at this very moment in time rather than the aggregated ones. Let's take a look at the 5 GHz page. Here, you'll immediately notice that all the channels on the chart now represent that of the 5 GHz band. Similarly to the AP Intelligent Capture page, if we wanted to drill down to its particular moment, we can actually drag our cursor on this chart as well to view a section of the chart in more detail. Scrolling down to the bottom, we also have an interference chart which will provide you with information such as the duty cycle percentages on each channel, different interferences observed such as deck-like phone and invalid channel. If you're suspecting that the reason why your clients are facing issues is due to the surrounding RF, the Intelligent Capture Spectrum Analysis feature will give you an immediate technical insight to the problem right away. With that being said, this concludes our presentation on Cisco DNA Center's Intelligent Capture. I hope you found this incredible feature to not only be exciting, but also to have great potential in supporting your wireless network. If you'd like to learn more, please refer to the description section of this video, where you'll find a link to an in-depth guide of this feature. Once again, thank you for watching, and until next time.